Okay, you're given a root, and the root's minus 1/2. And what does that mean? It means x plus 1/2 is a factor of that polynomial. Typically, we don't like to write it that way, but there's nothing wrong with writing that way. What we write down instead is 2x plus 1, and that's still going to give you minus 1/2 as a root. So that's my preference. And let me just erase what I have written over here. And what I'm going to do now is long division. And what do I know about the long division? It's going to work nicely, and you get a remainder 0. Well, let's see, what times 2 would give you 24? That would be 12, and it would have to be 12x squared. Write that down for you. So you get 24x cubed plus 12x squared. You subtract, you're going to get minus 62x squared plus 9x plus 20. Repeat. What's that going to be? Minus 31x, which would give you minus 62x squared minus 31x. You're going to subtract. What do you get there? 40x plus 20. Well, what times 2x would give you 40x? That would be plus 20. All right? So what do I know now? I know that this polynomial, which is 24x cubed minus 50x squared plus 9x plus 20 factors, whoops, put the equal sign there, factors into 2x plus 1 and 12x squared minus 31x plus 20. Again, there's a quadratic that remains there, and we want to get the other roots. I'm done with the division, so I'm going to get rid of the division now. And the reason for that is that I'm done with it. I don't need that anymore. And it worked out nicely. What are we going to do now? You're going to try to factor that. Let's put that down for you. So let's write this down. 2x plus 1. And let's take a look at that. I'm going to do it by trial and error. And let's see. Let's try something. I'm going to say 4x and 3x. And let's see. 5 and 4 minus. Let's see if that works. You do get 12x squared in the beginning, and you do get plus 20 in the end. Do you get the 31, minus 31 in the middle? Well, it's minus 16 minus 15, which is minus 31. So now I know the roots. And what are the roots going to be? The roots are minus 1/2. That's a given, by the way. The other one's going to be 5 quarters, and the last one's going to be 4/3. That's where those factors take on their zeros. Let's take a look at the key, see how we did, and see if we got that. 5 quarters, 4/3, and of course minus 1/2 was given. 5 quarters, 4/3, and minus 1/2 was given. All right? I do want to claim that when you look at this problem set over here, they give you pictures. You may want to look at those pictures. And this is figure 259. This is figure 259. And what I want to claim over here, looking at the picture, that I can clearly see the roots in the problem. And I'm going to write down the problem now, and this is this over here. And remember, this thing factored 2x plus 1. Let me remind you, a long time ago, right? 4x minus 5. 3x minus 4. And what were the roots again? Let's write them down again for you. Minus 1/2, 5 quarters, and 4/3. All right? Now let's talk about it one step at a time. And I'm going to start to list the roots on the graph. And the roots are the x-intercepts. So minus 1/2 definitely. That's clear as day. So what's this point over here? This would be minus 1/2, comma 0. Now granted, over here you might wonder what's going on over here. You kind of blow it up, and I hope you realize that that curve does go below the x-axis, and I'm seeing two x-intercepts here and there. Let's shrink it down again. And what do you get there? Well, this one here is going to be 4/3, comma 0. 4/3 is 1 and 1/3. And 5/4, 0 is going to be there. That's 1 1/4. So I got that. And the other question is, what's this point up here? That's the y-intercept. What's that point? That's fairly simple too. That's going to be when x is 0, y would be 20. And if you were to do sign analysis on this, this is f of x. I want to put down what I mean by that. Sign analysis is a problem over here. You have -1/2 where there's a 0. That's what's a circle there. You have a 0 at 5/4. And you have a 0 at 4/3. You take some test values here. Let me just change the color here. What's a good point between here? I would say 0. If you plug in 0, the first factor is positive. The second factor is negative. And the third factor is negative. If you multiply that out, positive times negative is going to be positive. All right, now what do I know? The curve, I may not know exactly what it looks like, but I do know it remains positive on that interval. All right? Now I'm going to take another test point over here. I can say a good test point over here would be 2. And what do you get for signs? The first factor would be positive. We're analyzing it here, by the way. The second factor would be positive. And the third factor would be positive. So what about here? Always positive. So after 4/3, it's still above the x-axis. Something like this. Now you might wonder why I'm delaying the number between 5/4 and 4/3. It's more difficult. Now let's go for a number below -1/2. And I'm going to say a good number over here would be -1. Plug it in. What do you get for the first factor? Negative. Second factor, again, we're talking about factors now. We're just looking at sign now. That's negative. And the third factor is going to be negative. What's a negative times a negative times a negative? It's negative. What about the curve over here? It's got to be below the x-axis or negative. All right, now granted, I want to point out, if you look at a decimal number, it might be easier for you. A decimal number 5/4, it's 1 1/4, so 1.25. And what's this guy over here? This is going to be 1 1/3, which is going to be repeating 3 3s. So what's a good number between there? I'm going to say 1.3 is a good number. Right, that's between them. Now, if you test it out, you're going to get, factor-wise for the factors, you can get positive. And 4 times 1.3, well, that's also going to be positive. And 3 times 1.3 minus 4, that's going to be negative. So I know what's negative over here. What does that mean? It's below the x-axis. Now, I'm exaggerating it a bit there, but you realize the machine does quite a good job of doing this. It really does. But you could get a general shape of the curve. You may not know the details like mins and maxes, but you know the general shape of it, which is not bad to know. All right? All right, thank you.